Good afternoon everyone, this is Yangchenla Bhutia, bearing a roll number 21NS0164, BSc 3rd semester, Department of Physics. Today I am here to present my physics presentation on the topic XPS technique or X-ray photoelectric spectroscopy technique. So here are my content that are as follows. You can see there. First of all, I would like to express my special thanks of gratitude to our teacher Dr. C.P. Khatibara sir for giving us this golden opportunity to present a presentation on those beautiful topics. So doing this presentation, I came to learn many new things, and I would like to thank my friends as well. So moving towards the introduction part, here are some points. Point number 1, X-ray photoelectron spectroscopy XPS, also known as electron spectroscopy for chemical analysis ESCA, is used to determine quantitative atomic composition and chemistry. Point number 2, a sample is irradiated with monochromatic X-rays, resulting in the emission of photoelectric whose energies are characteristics of the element within the sampling volume. Point number 3, an XPS spectra is created by plotting the number of electrons versus their binding energy. So moving towards the history of XPS, here are some points. Point number 1, Kai Sigban, 1918, inventor of modern-day XPS, was working at Uppsala University in Sweden in the 19th and 60s. Sigban was a physicist and chose to call his method electron spectroscopy for chemical analysis, as known as ESCA, because he understood the importance of the chemical information that XPS or ESCA can provide. Point number 3, Sigban shared the Nobel Prize for Physics in 1981 for his work. So, heading towards basic principle of XPS. XPS are mainly based on Einstein photoelectric effect. Many materials emit electrons when light shines upon them. Core electrons with kinetic energy EK are ejected by incident X-ray, as you can see the diagram below, and we get equation EK equals to H nu minus EB minus xSp. Here EK equals to kinetic energy, EB equals to binding energy, H equals to Planck constant, V equals to frequency of X-ray, xSp equals to spectrometer Vogt function. So here are some points. Point number 1, an X-ray beam usually comprises of K alpha X-rays is focused on the sample. Point number 2, the absorption of incident X-rays results in the ejection of electrons. And point number 3, the energy of the ejected electrons is measured by the detector. So this is the diagram for X-ray photoelectron spectroscopy. And this is the diagram of energy of the ejected electrons. So here are some more points related to XPS. Point number 1, each atom has unique XPS spectra. Point number 2, XPS can determine elemental composition, electrical or chemical state, and examine surface contamination. And last, point number 3, XPS is an elemental analysis technique that is unique in providing chemical state information of the detected element, such as distinguish between sulfate and sulfide form of element sulfur. Now let's talk about the inelastic mean free path denoted by lambda m. Point number 1, when an electron with kinetic energy E moves through a solid matrix M, it has a probability of traveling a certain distance before losing all or part of its energy due to an inelastic collision. Point number 2, the average distance traveled before such a collision is known as the inelastic mean free path, lambda ME. So continuing the inelastic mean free path, here comes the point number 3. Since the energy ranges used in XPS analysis are typically 50 to 1200 electron volt eV, the values of lambda are very small, corresponding to only a few monolayers. Point number 4, photoelectron mass originate from atomic layer very close to surface to be detected. Point number 3, therefore the XPS technique is very surface specific. Now here the question arises, what is XPS used for? XPS is used to measure, point number 1, elemental composition of the surface, point number 2, empirical formula of pure materials, point number 3, element that contaminate a surface, point number 4, chemical or electronic state of each element in the surface, point number 5, uniformity of elemental composition across the top surface. Point number 5, uniformity of elemental composition as a function of ion beam etching or depth profiling. Now heading towards the XPS instrument, there are 4 types of instrument. Number 1 is USB system, number 2 X-ray source, number 3 electron analyzer, and number 4 ion gun. So now let's see some points on ultra high vacuum system or UHV system. So UHV system allows longer photoelectric effect path length, or ultra high vacuum keeps surface clean, preventing the contamination to produce X-ray signal, as you can see below. So likewise, these are some points on X-ray source. You can. So this is some points on electron analyzer, as electron analyzers are lens system to collect photoelectrons, analyzer to filter electron energies, or detector to count electrons, and you can see the diagram below too. So this is the last type of XPS instrument called ion gun. It is mainly used as sample cleaning or depth profiling. Now moving towards the advantages of XPS, there are some points. Point number 1, XPS analysis is effective across a range of organic and inorganic materials. Point number 2, XPS is a leading technique for analyzing stainless steel passivation. Point number 2, XPS is also effective at identifying surface contaminants. Point number 4, XPS is an efficient testing method. Now let's see disadvantage of XPS. While very versatile, XPS is not a good choice for all material testing. There are a few of the reasons why you may wish you consider other type of material testing. Because point number 1, size matters. Point number 2, challenges with reproducibility. Point number 3, samples must be compatible with high vacuum environment. Last but not least, we are now here at conclusion part. So I would like to conclude my presentation by saying that XPS is a versatile technique and has been utilized in corrosion research for the past half century. It provides both quantitative and qualitative analysis of surface chemistry, oxygen state of various elements, etc. The unique findings XPS analysis can be used to confirm the incorporation of various reinforcements present in the coatings developed for corrosion protection, especially when embedded in the matrix. In the case of polymetric coatings, XPS can be deployed to confirm the presence, modification, and loading of nanocarriers. XPS technique can be effectively used in the post-corrosion analysis of bare substrate and numerous families of coating tested in various corrosive environments to properly understand the corrosion and protection mechanism. Thank you for watching my presentation.